Okay, so what we're going to look at is something called U substitution. If you remember the chain rule, this is kind of like undoing the chain rule. So let's start there. Um, and oh my goodness, sorry. There we go. Let's start there and we will go from there. So let's look at that chain rule again. So back a long time ago, we talked about if you had f of x equals, let's say, 4x squared plus 1 all to the 7th power, that quantity to the 7th power, the derivative of that would be 7 times the quantity of 4x squared plus 1. And then we had to multiply by the baby, remember the baby rule? Whoops, this would be to the 6th power. So 7 4x times the quantity of 4x squared plus 1 to the 6th, and then you would have to multiply by what's inside, the derivative of the inside, which would be 8x, and then we could simplify. We could get 56x times the quantity of 4x squared plus 1 to the 6th. So what we're going to do today is we're going to use U substitution, which kind of undoes the chain rule. That's how you can think of it. And we're going to start by just looking at patterns. So if I have this function, let's say I have x squared plus 1 to the 5th times 2x dx. This is more complicated than other problems that we've done because I actually have like an inside function here and then another function outside of the parentheses or square root. So U substitution is you have to figure out what do you want U to equal. That's the first thing. So what should the U equal in U substitution? So the U is usually parentheses, what's inside the parentheses, what's inside a square root. If you have a rational function like x over x squared plus 2, it's usually the denominator of a rational function. And what the U substitution does is we are going to change this whole function. So instead of being in terms of x, I'm going to substitute and I'm going to use the variable u. So u is going to be the variable that I'm going to integrate with. So on this problem, my u is going to equal x squared plus 1. Because it's the most complicated piece, it's not to the 5th power for my u. That 5th power just stays there. So my u is actually just equal to x squared plus 1. But when we integrate, we also need that differential, that dx. So if I integrate, I'm going to need in terms of du instead of dx. So what I can do then is I can take the derivative of u. So this process involves integrating and taking the derivative. So you have to remember both to do this. So the derivative of what I am letting u equal, so I let u equal x squared plus 1, the derivative of that would be du with respect to x, because the variable's x. I have my variable u and my variable x. So my derivative of u with respect to x would equal 2x. And the derivative of this was just 0, so don't worry about that. So then what I can do, and what we will do, is we're going to just do a simple multiplication, and I'm going to change this to say that du is equal to 2x dx. And you can kind of see, so think about substitution like when you were in Algebra 1 and Algebra 2, I'm going to substitute the variable u into this parenthesis. And for this whole piece right here, this 2x dx, I can actually substitute in du. So when I go to integrate, I'm going to have u to the 5th, because I'm substituting that, du. This function is a lot less complicated than this function. And we'll talk about integrating them in a second. But let's just look at some more patterns of maybe things that we could do. So let's say we have this function. Let's say we have x times the square root of x squared minus 3 dx. What should we let u equal? U is going to be inside that square root. So u is equal to x squared minus 3. Notice I don't involve the square root. It's just what's inside the square root. So the derivative of u with respect to x is going to equal 2x and then, 2x. And then remember that simple multiplication. If I move that over, is going to be du is equal to 2x dx. So how does that work? Well, I can put this u in here, and I have my dx, which would match here. I have my x that would match here. So this one would be, this one's a little bit more complicated. I have to think about this 2. Well, I don't really have a 2 here. So what I could say is I could say that if I divided by 2, du divided by 2 is equal to x dx. And now it matches x dx. So when I integrate, which we'll worry about in a little bit, it would be, I could put in the square root of u, because I have that. And then for x dx right here, what can I replace x dx with? I can replace it with du over 2. All right, so let's just try one more here. Let's say let's do a trig function. Let's do the cosine of x. I know you're excited, that's why I'm laughing to myself, because anytime I say trig, you guys in class would normally roll your eyes. So I'm just imagining that right now. Looking at this, what do you think you would let u equal? I would pick the sine because it's to the 4th power and it's in the denominator. So let's say that u is equal to sine of x. What is the derivative of u with respect to x? Well, the derivative of sine is cosine of x. That works out nice. And then, my goodness. And then if I multiply, I would get cosine of x dx. Does that match up? It's right here, so that matches up. So if I rewrite my integral, I would have du in the numerator, and in the denominator, what am I putting in for sine? I would have u to the 4th, and then you would integrate. All right, so I'm going to stop there for now. The first thing you're going to do is go to the next pages in Desmos, and all you're going to do is tell me u and du. That's what you have to do. You have to tell me u and du. We haven't even integrated yet. So do that, and then there'll be another little video.